Yes, Sarah. Oh, sorry, Rida.
Yes, ma'am.
I think we did this question or not?
Wait 1 second. We didn't do it, but you explained it.
Okay, so let's solve it then. So these are the multiples of 4. Now you have to find the multiples between 10 and 250. Clear?
Yeah.
So obviously 4 and 8 are not included. So the way to write it, like we find first of all the lowest multiple. So lowest multiple, like we have to start from 10, right? So 10 divided by 4. So if you do the division, so it will be 2 and the remainder will also be 2. So basically it's not perfectly divisible by 4. So 10 is not perfectly divisible. So if I take the, so basically 2 is the remainder. So that means you have to add 2 to obtain the first possible multiple of 4, isn't it?
Yes.
Yes. So 10 plus 2 will be 12. So the lowest multiple is 12. Got it?
Yes.
Okay. All right. So Rida, if you find it like a bit fast or whatever, you can just tell me honestly. So
Okay.
highest multiple. Now highest multiple. So you have to find between 10 and 250. So we see whether 250 is perfectly divisible by 4 or not. So if you divide it, you can like do it separately also. 250 divided by 4. So 4 into 6 is 24. Then 10. So 4 into 2 is 8. So you get a remainder 2. So it is 62, 2 by 4. So basically 250 is not perfectly divisible by 4. So it's not a multiple of 4. So in this case, you have to subtract 2 to obtain the highest possible multiple. Understood?
Yes.
So why I'm subtracting? Tell me.
To obtain the highest multiple.
Yeah, to obtain, because I want my multiples to be in the range from 10 to 250, right? If I will add, so I'll get 252, which I don't want. I need between 10 and 250, so that is why I'm subtracting in this case. So 248 is the last multiple which is possible between 10 and 250. Okay. Okay. So the highest multiple is.
Yes.
Yes, Hamna, can you hear me?
248.
Hamna, am I audible? If I'm audible, please write in the chat box yes or no. I can't hear you. Okay, so we have got the lowest multiple, we have got the highest multiple. So the series is, series will start from 12, right? Then you add 4 to it, you get 16. Then you add 4 to it, you get 20. And then it will actually end at 248. So this is the series. Now, since the difference is same, Hamna, please unmute your mic. This is an AP. Yeah, please write down up till here. Yes, written.
Yes, ma'am.
Okay, so we have obtained the series. Now we have to tell how many multiples of 4. How many means we have to find n, right? That means how many number of terms are there, right? Okay, so the formula is like we will write that we need to find n. We will write this, that we need to find n. Now the formula for nth term is an is equal to a plus n minus 1 into d. So we basically have to find how many terms are there. Now the last term, which is our an, is 248, which we have already found out, right? First term is 12, which we have got in the AP, and then plus n minus 1. And how much is d? D is 4. You can separately write it down also. So in this case, an is 248, a is 12, and d is 4 for the particular AP, which was 12, then 16, 20, and so on up to 248, right? Okay. Now find n. So just simplify this thing. So 248 minus 12 is equal to 4n minus 4. So this is 8 minus 2, 6, 3, 236, right? And then I'll take this 4 here. This is 4n. This is 240 is equal to 4n, and 240 divided by 4 is equal to n, and 60 is equal to n, or n is equal to 60. So there are 60 terms. So 60 multiples of 4, or you can write, so 60 multiples of 4 lies between 10 and 250. Sorry, 250.
Okay, ma'am.
Okay, next question. For what value of n are the nth term of two APs equal? Okay, that's simple. You have been given two APs, right? The first AP and the second AP. First AP, and then you will write second AP. Okay. So first AP is 63, 65, 67, and so on. And the second AP is 3, 10, 17, and so on, right? Okay. Now, for what value of n are the nth term of 2 AP equal? So we will find the nth term for both the AP. So we know that this is the general formula. So an is equal to a plus n minus 1 into d, right? So for the first AP, or like you can make a line in between, or you can write. So for the first AP, an, and for this, I'm calling it bn. Okay.
Yes, ma'am.
Okay. So let me write the this is a plus n minus 1 into d. Now what is a here? A is 63.
63.
How much is d here?
67.
Common difference. How do I calculate common difference, Rida? I subtract two terms. Difference, you know?
61.
No. See, this is the general representation, a, right? Next is a plus d. Next is a plus 2d. So basically, I'm adding a fixed number, which is d, to every term to obtain the next term. So that means if I subtract this term and this term, I should get the common difference, right? If I do a
Yes.
plus d and minus of a, what will I get? A minus a is 0, d I'll get. So if I subtract these two terms, I'll get d. Again, if I subtract these two terms, I get d. This is the common difference. That is why this is an AP, right?
Yeah.
So I subtract this, right? So d is 65 minus 63, which is 2. Got it?
Yes.
Yes. And because this is given that it is an AP, so I do not need to check the difference for all the terms. Since this is an AP, so it is obvious that the difference is same between the terms. Okay, so I can take any two terms to find the common difference. Got it?
Yes.
Okay. So put it in the formula. So your AN becomes A, that is 63 plus N minus 1 into D. So N minus 1 into D is 2, right? So
Yes.
this is 63 plus 2N minus 2. This is 61 plus 2N. So this is your AN, right? Like, okay, now for the second one, again, the formula is same. So B plus N minus 1 into D. So I'm just naming it by B just to differentiate. So B is actually the first term, which is 3, or you can write, right? Since if you just don't get confused. So first term B is 3, and the common difference.
7.
Yes, so this is 10 minus 3, which is 7. Good. So in this case, the nth term become B plus, that means 3 plus N minus 1 into D. So this is 3 plus 7N minus 7. So 3 minus 7 is how much? Minus 4 plus 7N. This is your Bn, right?
Yes.
7. Okay, fine. Now you have to find that value of N for which they become equal. Okay. So it is given that nth term of first AP is equal to nth term of second AP. So basically there is a particular value of N for which these becomes equal, right? We have to find that value, right?
Yeah.
Okay, so if I make them equal, so AN is equal to BN. That means your 61 plus how much was that? 2N, right?
Yeah.
Will be equal to minus 4 plus 7N. Okay, just solve it. It's simple. Find the value of N. So I'll bring this 4 here, 61 plus 4, which will be 7N minus 2N. So this is how much? 50, how much? 57, right? No, 50, no, sorry. Yes, is equal to 5N. Oh, sorry, this was adding. I'm sorry, I just subtracted. This is 65. Okay. So N will be 65 divided by 5. This will be equal to how much? 113. So N is equal to 13. So this is the value you have to find. Okay. Rida, I can do one thing. Since the other two students are absent today in the class, so I can just stop the AP here and then I can continue with their real numbers now. Is that okay?
Yes, ma'am.
Yeah, because we have done only 2 questions, so I can just stop here and it will be easier for me also in the next class. And at least we can complete the real numbers. So let me just open the book, come back to real numbers. So we are supposed to do exercise number 1.2 today, right?
Yes.
Okay, yeah, just a minute. Oh, where's my book? Okay, so exercise 1.2, we have done the introduction already. We discussed the theorem yesterday and also the relationship that HCF into LCM is equal to A into B, right? Of two numbers A and B. Now, first question.
Yes, ma'am.
Express each number as a product of its prime factors. So the first part is 140. So you have to express 140 into product of its prime factors. So just do prime factorization. How to do it? If you remember from the previous classes, like you write 150, okay? So you can start, you can see it is 14 is divisible by 2. It's also divisible by 7, right? Yes, Rida. So I can start my prime factorization by 2. Okay, so 2 into 7 is 14 and then 0. So 70 times basically it will be divided by 2. Then 70 will be divided by 35 times. So 2 into 3 is 6. Then 1 remainder, it will be 10 and 2, 5, right? Now 35 is not divisible by 2. It's not an even number. So I can try 5. So 5 into 7 is 35. Then 7 is a prime number. So it will be divided by itself only. So these are the factors. Yeah, am I audible, Rida? Please unmute yourself. I can't hear you.
Yes, ma'am.
Yeah, okay. So this is how the 40 is expressed as a product of primes. So I can write 140 is equal to 2 into 2 into 5 into 7. So we have expressed 140 into product of its prime factors. Got it? And in the theorem we studied, for example, again I do 140. Since I started with 2 here, right? The first prime factor I took 2. I can also start with 7. So 7 into 2 is 14 and then 20, right? Then it will be divided by 2 into 10 and then 2 into 5 and then 5 into 1. So this is what the theorem was saying, that the order of the prime factor is not important. Like you can start with any of the prime factor. We discussed it yesterday in the classroom.
Yes.
So again, I'm getting the same prime factor. So 7 into 2 into 2 into 5. So 2 times 2, I want 1 time 5 and 1 time 7. So same prime factorization I'll obtain, whether I start with 2, whether I start with 5, whether I start with 7. Does not matter. So that's how you have to do the second part also. Can you just try the fourth part for me? 5005. Please tell me what are the prime factors. So 5005, right?
Yeah.
Do the prime factorization and tell me. You can also write it like this, right? 2 to the power 2 into 5 into 7.
Yeah.
Doesn't matter, but like you can write, no problem.
Okay. 5 tens are 50.
Okay. So you are starting with 5. Okay. So 5, basically 5 is divisible by 5. So 5 into 1 is 5. Then you have 0.
Yeah. Then 1 more 0 and then 1.
Okay, fine. Then
7.
7. Okay, let me try. So 7 into 1 is 7. Then 3, 30. So 7 into 4 is 28, 21. Okay, right? Then
11.
okay, 11 into 1, then 33, right? 13.
Yeah. Then 13. Then
13. Okay, right. So the prime factorization are 5 into 7 into 11 into 13. Okay, that's good. So can you do the rest of the parts? Can I leave?
yeah. Okay. Sure.
Okay. Second question. Find the LCM and HCF of the following pairs of integrals and verify that LCM into LCM is equal to this thing. Okay. Right. So first pair is this 26 and 91. Okay. You have to find the LCM and HCF. So how to find LCM and HCF? First we do the prime factorization. Okay. So we will do prime factorization of 26 and we will also do prime factorization of 91. So for 26, it is divisible by 2. It's an even number. So 1 in 3 and then 13, right?
Yes.
So 26 can be written as 2 into 13. Okay. Now 91. Which number I can use here?
7.
7. Okay. 7 into 1, then 21. Okay. And then again 13. So 91 can be written as 7 into 13. Okay. Now what is HCF? HCF is the highest common factor, right?
Yeah.
So we see a number which is common in both the both the given numbers. So 13 and 13 is there in both one time. Okay. So HCF is 13. Okay. And LCM is least common multiple. So how to write LCM? So the number which is common, right? 13 and 13 is common. So we write it one time and all the rest of the numbers are taken. So 2 into 7. Yeah. So that's how we write it. So you can find out how much is the LCM here. Please multiply. So this is 26 into 7 to 14 and I think 182.
182.
Yeah, 182.
Yeah.
Okay. Now next you have to verify that LCM into HCF is equal to product of two numbers. So if you find HCF multiplied by LCM, how much you get? You get 13 multiplied by 182. Please tell me what you get here.
Two, 3, 6, 6.
Okay, 2366. All right. Now you check whether if you multiply the numbers, that means you multiply 26 into 91. See, these are the numbers which are given, right? Yeah. So you multiply how much you get 26 into 91? Please tell me.
Two, 3, 6, 6.
2366. Okay. So it is verified.
Yeah.
So like, or you can write, so HCF into LCM is equal to, or you can write like this, HCF of 26 and 91 multiplied by LCM of 26 and 91 is equal to 26 into 91. So this is verified.
Okay.
So similarly, you can do the other two parts, right?
Yeah.
Right. I'm coming to the third question now. Find the LCM and HCF of the following integers by applying the prime factorization method. Okay. First part, you have 12, 15, and 21. These are the three integers. Good. So you find the factors of 12, prime factors, find the prime factors of 15 and of 21. So let's start with 12. So 3 into 4, then 2 into 2, 2 into 1, right? Now 15, 3 into 5, 5 into 1, 21. So 3 into 7 and 7 into Yeah, 1, right?
Yeah.
So 12 can be written as 3 into 2 into 2. Now 15 will be written as 3 into 5, and 21 will be written as 3 into 7. So we have just done the prime factorization of each integer. Now you have to find LCM and HCF. Okay, so HCF, highest common factor, 3, right? And LCM, so 3 will be taken like one time and all the rest of the numbers. So 2 into 2, then 5 into 7. Is this clear? Yeah, so this 3 was actually common. This will be taken one time and all the other numbers will be taken. So please multiply it and get the answer. This will be the LCM. So that way you can do. Now, if you look at the second part here of the same question, if it is 17, 23, and 29, right?
Yeah.
They all are prime numbers. You can see prime numbers. What are prime numbers? I told you. How many factors are there?
2 factors.
Only 2 factors, yes. So 17 is divisible only by 17 and 1. So this is basically 1 into 17. That's it. Similarly, 23 is 1 into 23. And 29, it is 1 into 29. So these are the only 2 prime factors. What will be the HCF in this case?
1.
1, yes. And LCM?
17 into 23 into 29.
Yes, good. So you will just multiply and write the answer here. Okay, now come to fourth question. So have you noted?
Yeah.
Okay. First exercise actually is not in the syllabus now this year. So I've just omitted that. Fourth, given that HCF, okay, this is the given thing. HCF of this number 306 and 657, okay, is equal to 9. All right. Find LCM. So you have to find LCM of these two numbers. Okay. So basically your number, which is A, is 306 and B is 657, right? Okay, so we have seen the relationship that HCF of any two numbers A and B multiplied by LCM of these two numbers A and B is equal to product of the two numbers, right? We know this thing. Okay, so basically we have to find LCM. So from here, your LCM of the numbers A and B will become A into B divided by HCF. Yes?
Yes.
Okay, so that means the LCM will become A into B, that means 306 multiplied by 657 and divided by HCF, which is given 9. Or you can write LCM of this 306 comma 657. Okay. So you just find out the LCM. I'm leaving the calculation for you. And then you can match the answer. Answers are already given in the NCERT book. Okay. Next question. So Rida, can you complete the calculation part or should I do it?
I can complete.
Okay, you can complete. Fine. Next question. Explain why. No, fifth one, sorry. Check whether 6 to the power n, okay, can end with the digit 0 for any natural number n. What are natural numbers? The counting numbers like 1, 2, 3, 4. Okay. So for any natural number n, whether 6 to the power n is going to end with 0 or not, that we have to check. Now, for any number to end with 0, for example, I take the number, let's say 50. Okay. So any number which end with 0 is also always divisible by 5, isn't it? let's check, like I do the prime factorization of 50. So it will be 2 into 25, then 5 into 5, then 5 into 1. So 5 is always one of the factor, right? If I take a smaller one, let's say 10, the smallest one, which is having a 0 at the end. So 2 into 5 and 5 into 1, right? So because this is because any number which is having a 0 in the end, for example 30, or you take 20. So first of all, it is an even number. So 2 is always a factor, right?
Yeah.
And second, 5 will also be a factor always. You can do the prime factorization and check for any number which is ending with 0, you will always get at least 1 5, right? Okay. Now, if I do the prime factorization of 6, so 6 to the power n, 6 is basically 2 into 3 to the power n. Yes?
Yeah.
Okay. Now we don't have a 5 here. So basically, it's not going to have a 0 in the end because I don't have a 5 here. For it to end with 0, at least there should be 1 5. So I'll write here that for 6 to the power n to end with 0, it should be divisible by 5. Right?
Yeah.
Okay. Since its factors does not contain the prime 5, does not contain the prime number 5. So 6 to the power n cannot end with 0.
Okay.
Okay. Now next question. Sixth one. Explain why this and this are composite numbers. Okay. So there is a number which is 7 into 11 into 13 and plus 13. Okay. And the other one, 7 into how much? 6 into 5 into 4 into 3 into, sorry, into 3 into 2 into 1 and plus 5. Right? Have I written it correct? 7 6 5 4 3 2 1 7 6 5. Yeah. Okay, look at the first one. How will you simplify it? There is a multiplication sign, there is a addition sign also. So first of all, what will you do? Multiplication or addition?
Multiplication.
Yeah, so you will follow this rule, which is called BODMAS. You have studied in your previous classes. So first we do division, then we come to multiplication, and after that we do addition, right? So first multiplication. So that means 7 into 11 into 13, we will multiply first of all. And then we are going to add the next 13. Clear? So either you directly multiply it 7 into 11, or you can do one thing, you can take just 13 common. You can see 13 is there in the both the terms. So you will be left with 7 into 11 and plus 1, right? So your calculation will become small, that's it. So this will be 13 into 77 plus 1, right? So this will be 13 into 78. Clear?
Yeah.
Okay. And from here also you can see, or you can further like do prime factorization of 78 separately. So 2 into 3 is 6 and then 9, 3 into 1 into 13 and then 13, right? So you can just break it further, 13 into 2 into 3 into 13, right?
Yeah.
Okay. Now you can see, you have to check whether it is a composite number or not. So what is the definition of composite number? I told you. See, any number which is not a prime number is a composite number. So if it has more than two factors, right?
Yeah.
More than 2 factors is a composite number. If it has 2 factors, it's a prime number. If it has more than 2 factors, it's a composite number. So here I can see it has more than 2 factors, isn't it?
Yeah.
Okay, so since it has more than 2 factors, it is a composite number.
Okay, ma'am.
Yes? Okay. Now, similarly, you can do the next one. If I take this 7 into 6 into 5 into 4 into 3 into 2, right? Into 1 and plus 5. So this will be written as, I can take 5 common. So here I will be left with 7 into 6 into 4 into 3 into 2 into 1 and then plus 1. Okay. Now you have to multiply. So how much is this? You can break it down. So 7 into 6 is 42 into 4 into 3 is 12. 12 into 2 is 24 and then plus 1. Then 5 into, okay, 42 into 24. Please do it here. Yeah, 1008 and plus 1. This I'm getting. Please check the calculation. Have I done it correctly? Okay, so 5 into 1009, right? So you do prime factorization of 1009 now. Okay, can I try it with 3? No. Which number I can try? I think 7? No. Or you leave it like this, Rida. See. Yes, am I audible, Rida? Yes, Rida, say yes or no.
Yes, ma'am.
Okay. Now look here, you have to tell whether it is a composite number or not, right? You can further do prime factorization or you can leave it here like this also, because the definition of composite number is it has more than 2 factors. So here you can see one factor is 5, one factor is 1009, and then obviously you have 1, right? 1 is always a factor. So basically you have more than 2 factors here. So it's a composite number. Clear? So 3 factors are in front of you. One is 1, another is 5, another is 109. So basically you have more than 2 factors. So since it has more than 2 factors, it's a composite number.
Okay, ma'am.
Okay, yeah. Okay, the last question of this exercise now. Sorry, I have to erase. I have already used 20 pages. Now there's a circular path around a sports field, right? Sonia takes 18 minutes to drive one round of the field while Ravi takes 12 minutes, okay? Suppose they both start at the same point at the same time and go in the same direction. After how many minutes will they meet again? Okay. See, the situation is this. There's a circular park or path, right?
Yeah.
So there are two people, one is Sonia and one is Ravi. They both are starting from the same point, right?
Yeah.
Ravi and Sonia, they both have started from the same point. They are going in the same direction. But like if this is your Sonia and this is your Ravi, so Sonia is taking 18 minutes to cover the path and Ravi is taking 12 minutes to cover the path. So which one is going faster?
Ravi.
Ravi. So you have to tell, obviously, they will Ravi will complete the first round quickly, then Sonia, then there might be a situation when they will meet again at the same point. So you have to tell after how many minutes they will meet at the starting point. Now, how to do this question? Basically, you have to find the LCM, but like how will you arrive at the situation? So let me just take it stepwise. So time taken by Sonia, like which is given. This is given, right? Given thing. Time taken by Sonia is 18 minutes per round. Okay. And similarly, time taken by Ravi is 12 minutes per round. So this is given, right? This much. Okay. Now let Sonia meets Ravi after X rounds. Okay, you have to tell the number of rounds. Okay, not minutes. No, after how many minutes? Yeah, minutes you have to tell. Let Sonia meets Ravi after X rounds. Okay. So how much time will Sonia take? Time taken. See, for one round, she's taking 18 minutes. For X round, she will take 18 into X minutes. Yes?
Yes.
Okay. And similarly, or you can write, let Ravi meet Sonia after Y rounds. So time taken by Ravi will be how much, Rida?
12 into X.
12, no, Y.
Into Y.
Yes, 12 into Y minutes. Okay. Okay, so basically after this much minutes, they will meet again. Now we have to exactly find how many minutes. So there is a relation like 18x and 12y we know, but exact minutes we have to tell. Now, since they are meeting at a point, or since they are meeting at same point, so basically, this is the time when they are meeting. So that means at that particular time, 18x is equal to 12y. I mean, this time is equal to this time. Basically, this is the time when they are meeting, isn't it?
Yeah.
No, have you understood this thing? How I have written 18x into 12y. So x is actually when they meet. Okay, x is that round when they are meeting, right? Y is that round when they are meeting. So when they are meeting, so basically the time which is taken by Sonia will be equal to the time which is taken by Ravi. But we don't know what is X and Y. Like for uh, by which number I should multiply 18 and by which number I should multiply by 12 so that this time becomes equal. Got my point?
Yeah.
So I want to make this time equal, and now how will I write it? Let me just write and then I'll explain. Like X and Y are multiples of 18 and 12 respectively. See, X is multiplied by 18. So obviously X is a multiple of 18. Clear?
Yes.
Okay. and then y is multiplied by 12. So y is a multiple of 12, like 12 multiplied by something will give you y. Okay. Since we are finding the minimum time, okay, you just note down, Rida. I'll just explain the question again, but please note down first of all. Since we are finding the minimum time, we have to find the least common multiple of 18 and 12. That is, we have to find LCM of 18 and 12. Please write this, then I'll explain again. Sorry, it was 12 or it was 20? 12, yeah.
Okay, ma'am.
Okay. Now just listen here again. See, Rida, what I was doing is 18x into 12, sorry, is equal to 12y, right? Okay.
Yes.
Now this is also like time, and this is also time. This is the time taken by Sonia, and this was the time taken by Ravi. So in this question, we were asked that how many minutes will they meet again? After how many minutes? So basically at this particular instance they are meeting. So that is why I'm equating the time. Clear?
Yes.
So 18x is the time when Sonia is meeting Ravi, and 12y is the time when Ravi is meeting Sonia. That's what I assumed, x and y, right? So this is basically their meeting time. So at this particular time, they are both at the same place. Now we have to find the minimum time. That means since they are meeting first time, they can also meet the second time also. They can meet the third time also, because they are keep on rotating. But I have to find the first time they are meeting. So I have to find the smallest common multiple, like which is the same number, like x and y, I need to multiply so that this relationship becomes equal. I should get my LHS is equal to RHS. So what is the minimum common multiple I need to multiply this thing? So that is why I'm calculating LCM, the least multiple I want to find. Understood?
Yes.
So I mean, just understand the situation, and actually now you have to do the solution. So basically find the LCM of 18 and 12. So do the prime factorization of 18 and do the prime factorization of 12. So how much is 18? 2 into 9, that means 2 into 3 into 3. And 12 is 2 into 6, so 2 into 2 into 3, right? So the LCM becomes of
Yes.
18 and 12 will become, so 2 is common here and 1, 3 is also common, right? So 2 and 3 will come, and then you have one more 3, and then you have one more 2. So this is the LCM. So 2 into 3, 6. 6 into 3 is 18, and 18 into 2 is how much? 36. 36 minutes. Or so you write like they meet after 36 minutes.
Okay, ma'am.
Okay. So Rida, like next exercise we will be doing in the next class, but I just want to tell you one theorem, and then we will make use of that theorem in the next class, right? Okay. Next exercise is like important, like 1 or 2 question will definitely come from that in your boards also, final.
Okay.
Okay, so just note down a theorem. We will be using it in the proofs when we will be doing it. Theorem. Okay, let P be a prime number. Okay.
Yes.
Okay, and A is a positive integer. Right. So like
Yes.
underline this thing, positive integer. So this theorem is valid only for a positive integer. Okay. Now, if P divides A square, then P also divides A. That's it. This is the theorem.
Okay.
Yes. Okay, let's do one question also. Basically, this is a theorem that under root 2 is irrational. Okay. We know that under root, like root numbers, under root 2, under root 3, they are all irrational, but we have to prove that it is an irrational number. And in your book, it is given as theorem. That means you can directly use it anywhere. We know that under root 2 is irrational. What is a theorem? I mean, it has been proved, already proved. You can use it as a general rule. So root 2 is irrational, but we will prove it. We will show how. Okay. Now there is a method which is called the method of contradiction. First of all, we will assume that under root 2 is rational, and then we will prove it wrong. So this is the approach we are going to do. Fine.
Yes. Okay.
Okay. So assume under root 2 is rational. Okay. So if it is rational, see, the theorem is not mathematical. It will be all language. We will have to write everything. So the understanding is very important here. So please try to understand what I'm writing. Okay. There are no calculations here. Assume under root 2 is rational. So when you have a rational number, it is of the form of P by Q, that you know, right?
Yes.
So under root 2 will be of the form of P by Q. Fine. Where
Yes.
we know, where we know that Q is not equal to 0. Okay. And P and Q are integers. That also we know that P and Q are integers. This is important, right? Note it down, everything. Then you will understand why I'm writing everything. So P and Q are integers. Please underline this, integers. Okay. Now, when you have integers, so you can have a number like this. For example, 12 by 15, right?
Yeah.
Yes, Frida. Now there is a common factor. They both have a common factor of 3. So if I divide the both number by 3, I'll get 4 upon 5, right? So here in this form, it was having a common factor which was multiplied. That was 3. But in this case, there is no common factor involved. Both are prime numbers. All right.
Yeah.
So such numbers which do not have any common multiple, they are called co-primes. Right? I'll just write it down. Just understand this thing. Right?
Yeah.
So I have reduced like 12 and 15 into co-primes. So same thing I'll do here. I do not know what is P and what is Q. So they might have a common multiple between them. So I just want to eliminate that common multiple and I want to reduce it into co-primes. Understood?
Yeah.
So you will write like suppose P and Q have a common factor. Have a common factor. Okay. Other than 1. Obviously, see 1 is always there. So other than 1, they have a common factor. So we divide by the common factor. To get the simplest form. So now the simplest form is actually not P by Q, it is A upon B. I don't know what is A and B, but it's not P by Q anymore because I have divided it by the common term, right? So now where A and B are co-primes. Understood? What are co-primes? You can write in
Yes.
bracket, no common factor. This is co-prime so that you don't forget. So please write it up till here. So Rida, I think I'm going to stop here. So because it's like a long proof, we will continue in the next class. So please understand it up to here, right? Is it understood? So I've
Yes.
just assumed that root 2 is a rational number, so it should be of the form P by Q. But I don't know what is P and Q, so they might be having a common factor. So I just want to eliminate this common factor because I want to bring it into co-primes, right? Earlier they were integer, they can be any integer. So I have just simply divided by the common factor. So I have reduced it in the form of A by B. Now A and B are co-primes. That means they do not have any common factor other than 1.